Figure 1 shows a neuromuscular junction. This is the site of a chemical communication which is between a muscle cell and a nerve fiber. It's similar to the synapse between two neurons, as a nerve cell is able to divide into many branches with end plates. The end plates have receptors that are long protein molecules which can form paths through the membrane. The terminal branches from the nerve fiber can release a chemical called neurotransmitter acetylcholine by the synaptic vessels. This chemical binds the thousands of receptors and allow sodium ions to reach the end plates. This then allows the end plates to send electrical signals that allow the contraction of the muscle fiber through the T-tubules. Figure 2 shows the sliding filament theory. Once a stimulus has occurred, for example when you are about to perform a bicep curl, then the process of a motor unit will take place. In this process, the impulse jumps over the myelinated axon, which is the process of solitary conduction. Once at the end of the axon, the impulse travels through the nerve endings, which are connected to a muscle fiber, to reach the neuromuscular junction. This allows the impulse to reach the vesicles, where the all or none law applies, which is either all the fibers will contract or none of them will. Once at the vesicles, the acetylcholine within them allows the impulse to neurotransmit, and if enough ACH makes it across, then the impulse is allowed to continue and spread down the muscle fibers in multiple directions. Now the impulse travels through the T-tubules to reach the sarcoplasmic reticulum, where calcium is stored, and this calcium needs to go to the actin binding site, where there is troponin and tropomyosin, which blocks the myosin heads from being able to bind with their actin. So the calcium removes both the troponin and tropomyosin to allow myosin heads that are hydrolyzed by ATP to bind with actin to form a cross bridge and then a power stroke. Once this happens, the ATP becomes ADP to allow new cross bridges to form, and this enables the Z lines to move closer to one another, therefore contracting the muscle. And as they move closer together, the H zone, which is the central region, becomes shorter and shorter until it is no longer seen. Similar to the I band, which is rich in filaments that are made of actin, that also change in length. But the A band, which contains thick filaments of myosin, remains constant in length during contraction, and the myofibril contains actin and myosin filaments, which allows them to slide past one another. Motor neuron, which is shown in figure 3. This happens by electrical changes across the membrane of a neuron and is the transmission of a nerve impulse along a neuron from one side to another. An unstimulated neuron membrane is polarized, which means there is a difference in the electrical charge, which is both inside and outside the membrane. The inside is negative. The motor neuron has an axon, where the impulses travel along, and myelinated sheath, which acts as an insulator but also speeds up the impulse jumps. There's also a neuromuscular junction, muscle fibers, and nerve endings.